Okay, so today we'll review quickly the Pythagorean theorem that you learned about in geometry, as well as the converse of the Pythagorean theorem. We will review the concept or the term converse. But for the moment, let's just go quickly. I'm sure most of you remember, but just in case, because we will need it again when we get to our unit. We're going to review our distance formula, and the distance formula is derived from the Pythagorean theorem. So it's always good to remember that. I will add a third slide to this just to quickly talk about simplifying your radicals, because most of the time, and starting from now, most of the time you'll be always asked, especially when using the Pythagorean theorem in trigonometry, you will be asked to leave your answers in a radical simplified, okay? So what did Pythagoras discovered is like, wait a minute, if I have a right angle triangle, really important. Do you notice here that the right angle is given to you? Okay, it is stated that it's a right angle. So given a right angle triangle, isosceles, scalene, or equilateral, doesn't matter. No, equilateral actually cannot be. It has to be either isosceles or a scalene. It states that you have first A and B and C. First of all, let's get the language down. These are the legs when you have a right angle triangle, the legs, and this is the hypotenuse. Okay, the hypotenuse and the legs. But they already discovered that if you square the values or the length of the two legs, you get the length of the hypotenuse squared. Careful. I get a lot of students, they're like, but wait a minute, if I just square root everything here, doesn't it become just A plus B equals C? Remember that you can't do that. Mathematically, according to PEMDAS, you cannot take the square root until you add it here. Remember that the square root takes the place of a grouping symbol, meaning you don't need to put your parentheses there, but there are parentheses there, meaning you do have to compute your A squared plus B squared before you can square root. So this makes absolutely no sense. Please take this out of your minds right now. Okay? So let's quickly look at what it looks like visually and the way he came up with this, because some of you is like, what was he doing? What was he thinking, right? Some of you will see like he had a lot of time to waste. He probably did, but it's okay, That's what mathematicians are for. You just play around with things like this with theorem, using something that you've learned in geometry, using your inductive reasoning to come up with a proof, and that proof is part of the deductive reasoning part. Okay, so let's go back again to our drawings. So really what he's saying is like, wait a minute, if I create a square with this side, with this side here, and I create a square with this side. By the way, the squares are not perfect here. I just don't have enough room. So if this is A and this is B, well, this means that this is also A, and A, meaning this is the area is A square. Remember, it's A times A, right? And if you tell me that this is B, B, O, B, which is not, by the way, but if it is a square, right, by definition has 4 equal sides, meaning you find the area of this square. Well, it was discovered and proven that, and never refuted meaning that it's always worked. The length C here, you have your length C, and we'll change color because it looks weird. See, all of these sides here are congruent. You discover that you add the two areas of those smaller squares and you get the area of this one. It works every single time. Hence the theorem that we could use for so many things. You will see as we move on, it will become more and more popular. Actually, I'll add a quick slide at the end and we'll do a few examples. Okay. Next slide. We're going to talk about something very important. we have our converse here of the Pythagorean theorem. Meaning, what is a converse? A converse is when you switch the if and then statement in a sentence. Meaning, if, okay, I'm going to write the if statement for the Pythagorean theorem. If you have a right, I'm just going to move this a second here. If you have a right angle triangle, then a squared plus b squared equals c squared. You see my if, and then, sorry, I forgot an e. And then, okay, you have your if and then statement. If you have a right angle triangle, then the length of the two legs squared equals the length of the hypotenuse square. This is your Pythagorean theorem. But now let's switch the if and then statement. You leave the if and then there, You just switch the meaning of the two. Now let's talk about the converse. The converse would go that way. If a squared plus b squared, right, the lengths of the two legs square equals the length of the hypotenuse square, then the triangle is a right triangle. So you see, we just switched again. We took the if and then statement. And then, sorry, I keep forgetting to put the if and then statement. I mean, you leave the if and then there, you just switch the meaning of both, okay? So if you have a right angle triangle, then a squared plus b squared equals c squared. Now let's talk about the converse. The converse is if the length of my legs squared added together gives me the length of the hypotenuse square, then the triangle is a right triangle. So now we're going the other way around. So this is our converse. Okay, very, very important. I'm just going to put that smaller here. Actually, I'm just going to create another triangle here. So I'll just put it right here. Oh, no, here, sorry. Okay, so meaning if you are given this side, let's say I tell you this side measures 3, this side measures 4, and this one measures 5. I give you the 3 sides. You have to prove that this is a right angle. Do you notice I didn't put the right angle there? So let's try that. 3 squared plus 4 squared, does it equal 5 squared? Let's check it out. 9 plus 16, does 9 plus 16 equal 25? Yes. So what we can say, this is a right angle triangle. Whereas the Pythagorean theorem, I will give you the sides of the length of the two legs, and you have to find the third side. But then you will be given this, okay? So you need to be able to do both. Get a triangle and prove if it is or not a right triangle, given the side length, or vice versa. Given the side, the length of the legs, and you have to find the length of the hypotenuse, or other length for that matter. Okay. Now, do you notice that I gave you 3 whole numbers right here? And I knew that at the beginning. This is called a Pythagorean triple, meaning a triple means that it just means that a Pythagorean triple just means that the 3 lengths give you their whole numbers. Because most of the time when you use the Pythagorean theorem, you're going to notice that the third side ends up being a radical, which is fine. Let's do an example of that on next page. So again, let's get a triangle. And I want to tell you that the 2 legs measure, this one measures, 9. And this one measures 7. And I'm asking you for this side. So we're going to go 9 squared plus 7 squared equals c squared. So here we have 81 plus 49. What is 81 plus 49? Gives you 130, right? So 81, but then remember that is square root. 130 cannot be simplified, so you're just going to leave it like this, 130. Get used to leave your answers in square root.